Now that we know how to expand, let's learn the reverse, factorization. This means expressing a term as a product of simpler expressions. Think of it as reverse multiplication, finding what was multiplied together in order to obtain an expression. This is what I mean by reverse multiplication. The number 12 can be obtained by doing 3 times 4, 2 times 6, or 2 times 2 times 3. The easiest method is to take out the greatest common factor. Let's take a look at this example, 14mx plus 35my minus 7m. So to factorize 14mx plus 35my minus 7m, we will look for what's common in all the terms. Each of them has an m, and each number can be divided by 7. So our greatest common factor is 7m. When we take out 7m, we divide each term by it, which gives us 2x, 5y, and negative 1. So the fully factorized form is 7m multiplied by bracket 2x plus 5y minus 1 close bracket. That's how we use common factors to simplify algebraic expressions. Now, we will learn how to factorize quadratic expressions, those with the term ax squared plus bx plus c. The goal is to find two brackets that multiply back to the original quadratic equation. To do that, we find two numbers that multiply to give a multiplied by c and add to give b. Let us take a look at this example. 10x squared minus 7x minus 12 would give us 2x minus 3 multiplied by 5x plus 4. But let's see a simpler method. Let's use the square or box method to factorize 10x squared minus 7x minus 12. As we learned before, we need to find two numbers that multiply to give AC and add to give B. So we multiply 10 and minus 12 to get minus 120, since 10 is A and minus 12 is C. Now we need two numbers that multiply to give us minus 120 and add to give us minus 7. We then find minus 15 and 8. So we can express 10x squared minus 7x minus 12 as 10x squared minus 15x plus 8x minus 12. Next, draw a box and place each term in a corner. Find what's common across each row and column. The common brackets are then 2x minus 3 and 5x plus 4. So the factorized form is 2x minus 3 multiplied by 5x plus 4. That's how the square method works. It helps you see the factors clearly. Here's another example. Try it for yourself first and then check the answer. So you have to factorize 6x squared plus 7x minus 3. Did you manage to get the correct answer? If not, let's go through the working step by step. We will use the box method to factorize 6x squared plus 7x minus 3. So first, we multiply 6 and minus 3 to get minus 18. We then find two numbers that multiply to give us minus 18 and add to give us 7. That will give us 9 and minus 2. We then simplify this into 6x squared plus 9x minus 2x minus 3 in order for us to see the terms more clearly. We then draw a box with those four terms and find the common factors across the rows and columns. The common bracket is 2x plus 3 and the outer factors are 3x minus 1. So we will get 2x plus 3 multiplied by 3x minus 1. Now, instead of doing all those steps, you can often spot special patterns. Some examples are given in the slide. Let's take a look at some examples and practice identifying patterns. The first expression, x squared minus 12x plus 36, looks like a perfect square because 36 is equal to 6 squared. And the middle term is minus 12x, which is equal to minus 2 times 6 times minus x. That is how we are able to get x squared minus 12x plus 36 is equal to x minus 6, and then square. The second, where we have to factorize 16x squared minus 49y squared, is a difference of two squares, where 16x squared is obtained from 4x squared And 49y squared is obtained from the square of 7y. This is how we get 16x squared minus 49y squared equals to 4x plus 7y multiplied by 4x minus 7y. Sometimes you can't take one common factor from the entire expression, but you can take common factors in groups. For example, let's take a look at ax plus bx plus kay plus kby. We will group the first two terms and the last two terms together. And we'll find the factors in these groups. So for the first group, the factor is a, and for the second group, the factor is ky. Then we will combine the factors in each group, because both of them have a plus b, to get the final answer, a plus b multiplied by x plus ky. Now let's try this example together. We have to factorize pq plus pr plus 2sq plus 2sr. Let's first group the terms pq and pr together and 2sq and 2sr together. When we do so, we are able to see the common factor in each of these individual groups. So for the first group, the common factor is p, and for the second group, the common factor is 2s. Then the common factor between these two groups is q plus r and q plus r. So we are able to simplify it into p plus 2s multiplied by q plus r to get the final answer. Now that we're nearing the end of the lesson, let's take a look at some common mistakes students make when factorizing. The first mistake is that many forget the greatest common factor. For example, when we take a look at 2x squared plus 4x, some students stop by factorizing only the 2, but both of them still have a common factor of x. So the correct factorized form is 2x, x plus 2. Always check if there's still a common factor left. The second common mistake many students make is sign errors. Always check that your final answer expands to the correct expression. In this case, x squared minus 5x plus 6 is actually equal to x minus 6 multiplied by x plus 1. This would give us the correct final expression. Here's the golden rule. After factorizing, always expand to check your answer. Thank you for listening.
Smash your maths exams. Download Learn Maths Today for real exam questions and achieve top marks.